I researched the blue-throated hummingbird and how the Lampornis clemenceae opens its beak and expands its lower mandible so that it can obtain the nutrients it needs to survive as it combats climate change. So the blue-throated hummingbird can be predominantly found in northern Mexico, and it stays there year-round. Mexico is currently suffering immensely due to climate change, and there's an inaccessibility of water. This graph depicts that by 2100, approximately 90 consecutive dry days will be intact, and this leaves variability for 33% of the year to be dry days. That means that 120 days of the year will be without rain or water. So this is problematic for my Hummer because this enables there to be less plants, and with less plants, there are less nutrients that it can obtain. So the blue-throated hummingbird has adapted so that it can get nutrients and protein from insects. This image here shows how the beak of the hummingbird is narrow and very long, which helps it so it can go deep into the flower to obtain nectar. So, how does this hummingbird get its nutrients from insects while in flight? The hummingbird has adapted so that it can open its beak from the base by 20 degrees and expand its lower mandible to a greater surface area so it can more easily catch insects while in flight. And also, high-speed video found that as soon as the hummingbird opens its beak, it almost immediately snaps back into its natural position to ensure capture of its prey. Over here, you can see the food web for the blue-throated hummingbird and how it includes both insects and plants, which is why it needs this adaptation in order to survive. And if the blue-throated hummingbird were to go extinct due to climate change, this would be extremely problematic for the global food supply because with the little amount of plants left, that would be detrimental because the blue-throated hummingbird is a pollinator. So without the pollinator, there would be less plants, and with less plants, there would be less blue-throated hummingbirds. So it's a vicious cycle that would cause a decimation of our global food supply. And then if we look at figure 5, the flow chart illustrates the cause and effect of the drought. So this just takes a specific circumstance with like an example of a plant and an example of an insect that the blue-throated hummingbird eats. So the drought causes the honeysuckle population to go down, and that makes it inaccessible to the blue-throated hummingbird. And thus, the blue-throated hummingbird has to get nutrients from something else, in this case, wasps. So this shows how the blue-throated hummingbird has this adaptation in which allows the food chain to maintain balance. And in conclusion, the blue-throated hummingbird has adapted to open its beak by 20 degrees and expand the surface area of its lower mandible so that it can overcome the effects of climate change, which proves the importance of this adaptation. Any questions?
How does the opening of the beak allow it to eat insects?
Okay, so basically, blue-throated hummingbird, its beak is super narrow and small, so when it opens its beak, it also expands the bottom of the surface area, which is why it's actually able to eat the insects that would be bigger than its beak in this picture, because it's similar to that of a needle. So yeah, and it's also this species is the hummingbird that eats the most insects out of all other hummingbirds. So that adaptation has to do with that in this case. Yes.
So I was wondering if the blue-throated hummingbird is able to eat like insects like wasps, then why is like drought a problem if there aren't any plants? Like why can't it just supplement one with the other?
Oh, yeah, so they do use insects as a supplement for that because it provides protein. So it doesn't only survive on nectar, but it's had to turn to insects more than they should because nectar is like a primary source of nutrients. And like the blue-throated hummingbirds have to pollinate other plants when they get nectar because the pollen gets stuck on their beak, which is why they are pollinators as they go and feed on other flowers and spread the pollen. So yeah, this adaptation helps them to maintain balance because it would be problematic if they couldn't.
So when you say it opens its beak by 20 degrees, is that 20 degrees more than before?
Yeah, it opens its beak 20 degrees, like from from natural position, so it's like extremely wide. And then it can also range to 25 degrees, but 20 degrees was like majority for my sources, so I went with that. But yeah.
So like the surface area
Of the lower part of the beak expands. Oh yeah, and then it also like opens its beak this way so that the insect doesn't get stuck in its throat. Because if it were to just open from like the front and not expand, it would like easily get caught because it can't like process it.
Can you explain your graph better?
Okay. Yeah. So here in 2100, you can see that it shows about 91 days where this like red line is. That's the 90 days of consecutive dry days. So this isn't counting like random spurs of drought. This is counting like days in a row where there's no rainwater. So this red line shows that by 2100 it predicts that 90 days will be consecutive days without rain. And then this, what I said, leaves variability for 33% of the years, of the days of the year to be drought days. That's this section right above. You see how it's like lightly shaded? So that's the variability for how it could be even 120 days of the year. Are there any other questions? Really good. Okay. Cool.